I was at work yesterday and I was talking to a fellow employee and said something about evolution or something about something that had been evolutionarily developed. And he asked me, oh, don't you believe in God? And I don't know what that means. I don't know what that means when someone says, do you believe in God? Because I think that if there is a God, if there is, I don't believe in some anthropomorphized grandfatherly figure who's in the sky, some gentlemanly craftsman who, benevolently looks over everyone and everything all the time. I don't believe that. That's an anthropomorphic vision. That's people taking things that are cognitively familiar to them and trying to um, create an analog that's similar to something that is recognizable to us. I think if there is a God in the universe, it's going to be something that's so overwhelmingly profound and beyond anything that we can imagine that the human mind just simply isn't capable of trying to explain that. Um, but that being said, this guy just can't seem to understand. When I tried to start to explain to him that we can actually see the physical record of evolution in the fossil record, we can actually physically see how these transformations have taken place. And I tried to start to explain to him that a single cell organism, a microbacteria, or you know some type of like maybe in the water, like a photoplankton, some chemical reaction that takes place that sort of starts to create the amino acids and the fundamental basis of life, um, all the way through to some more complex creature maybe that lives some kind of something that's similar to an amoeba, or uh, something that lives in the ocean or lives in a pond someplace that develops this spot on its back that sort of can detect light. It's sensitive to light, it's sensitive to radiation. And then, over millions and millions of years of trial and error, what ultimately comes down to what gives us the genetic advantage. If something gives us the genetic advantage, that trait is going to carry on. It's going to be the next generation is going to be dominant in that trait, and animals or creatures that don't have that trait are going to dissipate from the confines of the environment. That that whatever that creature is that has that sunspot on its back, through evolution, trial and error, that sunspot gets even more refined, so it can not only detect light, but it can sort of differentiate the difference in shapes, or maybe colors, or the amount of radiation that's coming off of something, which gives us the idea of colors in our minds. um, I know that's not a very scientific way to explain that, but you know eventually that mutation that's occurred in that animal becomes what we know today is an eyeball. It's formed over a long period of time, or we can see that kind of if you ever looked at if there's a certain type of fish that grows in. I know they certainly find them off the New England coast where I'm from. um, they have a fish called a flounder, and the flounder's got eyeballs on both sides of both sides of its head, because it basically swims sideways, and the eyeballs are sort of looking up, typically, um, because they have developed that way, so that they lay flat in the sand on the ocean floor, and it sort of hides them from predators, but it also allows them to see upward by having two eyes, on one side of their head. So that's an evolutionary development that's taken place. It's occurred over millions of years, because it gives that particular fish an advantage. It allows that fish to survive and pass on as many copies of its genes to the next generation as possible.